Okay, so I'm going to talk about complete and net ionic equations, how to balance them, what the total molecular net means, oxidation states, and types of reactions. And I'm not exactly sure what you're going over in class, but hopefully this will help clear some of it up. If you need anything specific that I don't cover, feel free to ask me. So the first thing we're going to do is figure out how to get the complete and net ionic balanced equation. So we're going to work through an example step by step. And I've provided a list of steps for how to do pretty much any problem like this. This is just the example problem, and these are the steps. So if you want to pause the video right here and write those down so you'll have them, that would be great. Okay? Alright, so we're going to work through it. So let's say we have these reactants. So we don't have a total equation. We don't have the products. We just have these reactants. Okay? So the first thing we have to do is figure out what are the products. And the way we do this is called the inner with inner and outer with outer method. And what I mean by that is obviously you have K and Cl. So Cl would be your inner and K would be your outer. Pb would be your inner, closer to the plus sign, and nitrate would be your outer. Alright, so if it helps you to color code, you can kind of do it like that. So those two will go together, and I can underline them. Those are our inner, so I'll write that. And potassium and nitrate would be our outer. Okay, so we're going to put those together. And we always put the metal before the non-metal, right? And we can tell if it's a metal or non-metal by the periodic table. If it's on the left, it's a metal. If it's on the right, it's a non-metal. Remember, on the left, they're going to have positive oxidation states or positive charges normally, and on the left, they'll have negative. So we always put the metal, then the non-metal. That's just how we write it. Okay? So between Cl and Pb, chlorine and lead, which one would be the metal? Well, it would be Pb because lead is on the left side of the table. Alright, what charge does lead usually have? Well, let me pull up my periodic table here. And remember, we can tell what the charge will be based on which group that it's found in. So where is lead? Lead is in group 6. So it's going to have a 1, 2 minus 3. Lead normally has a 2 plus charge. Sorry, yeah, it has a 2 plus charge. Okay. Alright, and it's going to go with this chlorine. Chlorine usually has a 1 minus charge. Okay, so we'll put those together and we'll balance it. Remember, we bring these down, we do that cross method. So Pb will get this 1. We don't have to write 1, it's understood. And chlorine will get the 2. So that'll be one of our products. So that's one of them. Okay, now I got to figure out the other one. So we'll combine our outer. So we have potassium. Potassium usually has a 1 plus charge, and it is a metal. And nitrate is a non-metal. So nitrate normally has a 1 minus charge. So we'll balance it, put them together. A 1 and a 1 cancels, so it'll just be KNO3, and I don't have room to write it, but it's also one of our products up here. Those are our 2 products. Okay, so the next thing we have to do is we have to balance this equation that we have. We have our reactants and we have our products, and we have to balance it. And when we balance it, that'll be our molecular formula. That will be showing us how many molecules of each of the constituents that we have in the equation. So let's balance it. So we have KCl plus PbNO3 2 gives us PbCl2 and KNO3 3. All right. So balancing to each their own, however you like to do it. So I normally will write what I have on each side. I have Cl, Cl, lead, lead, and nitrate. All right. So on this side I have 1. On this side I have 1. For chlorine I have 1. Chlorine on this side I have 2. For lead I have 1. For lead I have 1. For nitrate I have 2. For nitrate I have 1. Okay, so it's not balanced, so I got to balance it. So how can I get this balanced? Let's see. Well, I know I'm going to need more chlorine on this side. So if I put a 2 here, that's going to increase this to a 2 as well, which means that will also become a 2, which means now I need a 2 in potassium on this side. So if I put a 2 here, okay, that brings this to a 2, but that also made this nitrate go to a 2. Does it match? 2, 2, 2, 2, 1, 1, 2, 2. So it's balanced. So this would be, sorry, I'm having to do this one-handed. When you get the idea. That would be your molecular equation. It's balanced. Now, if you hadn't balanced it, it would not be right. So you have to balance it. All right. Next step. We have to figure out the complete net ionic equation. And we do that by breaking this equation apart into its separate ions. We have to account for all of the ions. Now, by doing that, we have to determine if each of the ions, well, or before doing that, we have to determine if each of the reactants and the products are aqueous or not aqueous, because aqueous is related to its ionic nature because it's dissolvable in water. So we can do this by looking at a solubility table. So you can Google a solubility table, and here is an example of what one looks like. Okay, so that's where I'm getting this information about whether it's aqueous or not. So I can look one up and it'll tell me, so if it's soluble in water, it would be aqueous. And there are exceptions that you have to note. And if it's an exception and it's insoluble in water, that means it's a solid. So we'll base it on that. So we'll go through each one and determine. So we'll rewrite our equation. All right, so first one we have is potassium chloride. So for potassium chloride, we need to know if it's aqueous or not aqueous. So if we look for chloride on our table, most chlorides right here will be soluble in water except for these, but we don't have any of those. So we know that this solution is going to be aqueous. Okay? All right, we do the same thing for lead nitrate. So we look up here, we look for lead or nitrate, see if it's on here. And sometimes you may have to look for more than one solubility table. There isn't one that encompasses all that I've found. You may just have to look for whatever you need specifically. I do know that nitrate is probably going to be aqueous, even though it's not on here. See, or lead, if I can find lead, I'm pretty sure. See, these compounds with lead are going to be solids. Let's see, do we have any of those? PbCl, oh, look here. PbCl is going to be a solid, and we have that right here, so that told us that one. So that one's going to be a solid, okay? Potassium, no, see, potassium. a nitrate. Well, both of these with nitrate. I don't see any exceptions that have lead nitrate, because nitrate is usually aqueous. So this one's going to be aqueous, and I just know that. But you could look it up. You could type in Google, what's the solubility. Oh, there's nitrate. I'm sorry. I'm blind. There's nitrate right there. So it is soluble. Okay. But you could Google it either way. All right. So once we've determined that, it kind of tells us about how these are going to behave. And we need to know that. All right, so now we're going to break it apart. So we're going to break each compound apart into its constituent ions. So, and you have to account for where you balance it. So if you have 2, you have 2K and 2Cl. So you have to write all of that out. So I have 2 potassium. And potassium has a plus charge. We'll do a plus sign. You're going to add all of them up. So I have, this is distributed to both of these. So I have a 2 chlorine. Chlorine is a minus charge. All right, lead. I have 1, and it's going to have a 2 plus charge. Nitrate, minus charge. Now, this solid compound, we cannot break it up because it's a solid. It's not soluble in water. So when we put these compounds in water, they're going to dissolve and they're going to separate into these ions. And that's why we look at this type of equation, to see how everything's going to behave. However, this solid, if I put it in water, it's not going to separate, so we cannot separate it. So we're going to leave it together. And then we're going to finish this. Potassium plus charge plus 2 nitrate. And remember that 2 distributes to both of those. And I'm trying to remember if you put the solid, I know you put it in the net ion, total net. Should be able to tell from an example. Yeah, you keep the solid in the equation, you just don't write it broken up. So I'll still write my solid beside of that. I just don't have room. But I'm just not going to break it up because it's a solid. And you do that for any solid that you have. So this is what's called the total, keyword total, because it's like super long and it has everything. Total net ionic. Well, actually, it's not the net. It's the total. Don't confuse yourself. It's the total ionic equation. It has the total of everything. All right. Once we have that, we can find the net ionic. And net means what we actually use. Think of net, that word, as being what is important and what we'll actually use. So it's going to be the 2 reactants that we really need to make that solid. And really and truly, a lot of what we have is spectator ions. So a lot of this stuff in the reaction is there, but it's not participating. So the net helps us focus on what is participating. So to get what's participating, we have to eliminate all spectator ions. Spectator ions are ions that are present on the reactant side and the product side, but they're not really participating. And you can identify them by looking for what you have on both sides that are the same. It's kind of like balancing an equation in math. If you have something on the left side and something on the right side, it cancels out. So if I have a 2K plus and a 2K plus, cancels. Okay. I have NO3, NO3, cancels. Okay, so that eliminated all of my spectator ions. So now I just look at what's left. And what I have left is 2Cl minus plus Pb2 plus yields PbCl2. This would be my net ionic equation. Note, a way you can check and make sure you haven't made any errors in your process and that this is correct is by looking and making sure that you have two ions that if you put them together, you will get this outcome. So can I put together Cl and can I put together lead and get PbCl? Well, yeah, of course, duh. I got Cl and Pb, Cl and Pb. Vice versa. So you have to be able to, it has to make sense. Like these two have to equal this. And another way to check is to make sure that this outcome, this product that you have, is the solid that you identified earlier. So our solid was PbCl2, PbCl2. So that's right. So that's our net ionic equation. So that is an example of how to do one of those. It's kind of involved, but the key is memorizing those basic steps and following the steps, and that will help you remember how to do it.